So, hello everyone. This is my solution the for the addressing mode assessment. So, in exercise one, sorry, let me share again. In exercise one, uh, what we have to do is identify the addressing mode used for the specific address. So, for this one, for number one, uh, for number one, it's moving BX to AX. So this is register addressing mode. So register addressing mode is just copying the register into another register. So next is direct addressing mode. So we have here an address which is 1234H, and it will be stored to an in a register AX. So it's a direct addressing mode. So next one is register indirect addressing mode. So instead of an address, we use a register storing an address uh, into a register. So next is moving AX into the product into the sum of BP plus DI. So it's base index addressing mode because uh, uh, the offset address and the operand is computed by summing the base first. So if you're adding two index, and then you're going to put it inside and register. If you're going to add two addresses, and then you're going to put it uh, in an address in a register specific, uh, it will be a base index register. So if we have this two, we have this both of these two, it will be the value of this uh, will be moving AX into the value of these two, BP plus DI. Yung next is this one. So base index with displacement addressing mode. So may displacement address tayo, which is 08H, plus these two are base index. So from the example, this one is based on this one with a displacement. So it's just the same. We'll add this pool and then move it to CX. So this one is register indirect addressing mode. So the same as number three, we will register AX into DI. This one is base addressing mode. So this one, uh, instead of base index, we have an address, and it will mi- uh, be minus to BP, which is register, and whatever the result of BP and 10H will be moved to AX. Next is immediate addressing mode, the simple stuff. So the value 5678 will be moved into AX. So uh, this in turn will make AX have a value of 5, 5, 6, 7, 8 H. So that's the whole value. Then register indirect again. We'll just move a uh, a register with an address inside, since it has a bracket, into AX. So AX will be uh, AX will have the value of will have the value of BX inside. So let's say BX has 1, 1, 3, 3, 4 each. So uh, AX will then have AX will be this. Okay, then. Okay, next move. Let's move to exercise number 2. So for exercise number 2, we will write a codes for specific addressing mode. So we'll uh, it will be the reverse of exercise 1. So for move AX 00x55AA, this is in immediate, similar to number 8 here at exercise number 1. We will move immediately the address into a register. So register addressing, the same stuff. We'll move the register uh, into another register. And direct addressing is uh, we have a we have an address with brackets moving into a register. Register indirect. We have a register storing an address moving it to AX to another register. Index register is we're adding a register and a and a dis, and an address, and then after getting the result of DI plus 10H, we will move it to a lower. And then the last number for exercise 2, move AX, BX plus SI. BX plus SI is gonna be moved to AX, which is base index addressing. Uh, Base index addressing is just adding two register. So we have two register here, two registers, and then we'll move to AX. There you go. So that's so far. Then now let's move on to exercise 3. So for exercise number 3, there's a problem. Given the base address is 1000H, segment address is 2000H, and a displacement of 0010H. So for number 1, we're going to compute the physical address for instruction move AX, this one, move AX to 100H. So the segment is 2000H, and our displacement, this is our displacement, is 1000H. So 1000H, 2 plus 1000, it will be 3000. So AX will then have the value of 3000 AX. This one. Then for number 2, uh, the same as usual, the same as number 1, but this time we're using what's this? We're using a base index with displacement addressing mode. So we have the segment 2000 given. BX is already given a value of 1234 each, and SI having 4321 reverse, and our displacement value is 10H. So if we add all of this, 1 plus 4 is 7. 2 plus 1 is 3, plus 4 is 7. 0, 2, and 3 will be 5. 3 plus 2 is 3 plus 2 plus 1 will be 6, and then 4 plus 1 plus 0 is going to be 5. So AX will then have a value of 75,600, 7,565. There you go. So that's it. And then for exercise 4, uh, For exercise 4, we're going to debug and analyze. So analyze the following snippet and answer the following question. So for number 1, we're going to identify the addressing mode used in each instruction. So for my number 1, um, this is the entire snippet, this one. And then for each line, we're gonna identify uh, which addressing modes are used. So since we are having a register in a bracket, it's always gonna be a register indirect addressing. This one, we're moving 2000H into SI, so it's already immediate addressing. And this one, we're adding an address to a register, and then the result of this will be moved to AX, which will be an index addressing. And then if we're moving a register into another register in a bracket, that will be register indirect addressing. So for 2, uh, there's a there's a condition. Uh, if yung memory location daw ng 200H is 1234H. So if 2000H, if you have an address of 2000H, it will always be 1234. It will store a value of 1234H. And if you have a value of 2000H, it will store 5678H. So, ang explanation dito, since move AX into SI, so SI already have 2000H here, we move 2000H into SI, and then SI having the brackets SI having the bracket means it has the value of 2000H, and 2000H have a value of 1234H. So ngayon, ang mangyayari, eto siya. So, si SI merong laman na 2000H, yun nga yung meaning ng bracket niya, meron pa siyang laman, which 2000H, ang laman niya is 1234H. So ngayon, si AX na daw, kasi minove natin sa SI sa AX, ang laman ni AX is 1234H. So ngayon, SI plus 10H. Si sorry. Si SI kasi ang laman niya is 2000H. So 2000H plus 10H, it will be 2010H. So ang laman nga ng 2010H is 567H. So ang laman niya ngayon is 5678. So ngayon, ipag-add down natin siya. So AX plus yung sum nito. So it will be this. 5678 plus si 1234H. So ngayon, makukuha natin yung total na 6, 8, A, C, H. So A is 10 kasi 3 plus 7 is 10. And 8 plus 4 is 12. So magiging C. So ngayon, ang result niya is AX is equivalent to 68 ACH. I-move siya sa DI. So ang mangyayari, final is DI will have AX, and AX will have 68 ACH. So ngayon, ang total na laman ni DI is this. So ang ilalagay sa DI is yung total. Okay. So ayan yung for exercise number 4, number 2. So for exercise number 5, okay. So this is for exercise number 5. For the last exercise, gagawa ng simple code, small assembly program. So for number 1 daw, loads the value 0x oh sorry, di ko nalagay yung x dito. Pero ayan, 0x, sabihin natin may x na lang dito. Hindi ko nasulat. So 0x, A, B, C, D, H. Uh, gawin ko lang red. Ayan. So ngayon, i-move daw si 0x, A, B, C, D, H uh, sa address na 3000H. Ngayon, si 3000H, i-move kay AX. So ngayon, ang mangyayari dito, ang value ngayon ni AX is 0, yun nga, si 0x, A, B, C, D, H. Ayan. So ngayon, si AX daw, si AX na may laman na 0x, A, B, C, D, H, i-move siya kay BX. So for simplicity, sabihin na lang natin si AX muna ang laman niya is ang laman ni BX is si 3000H na naglalaman ng AX. Then, si DI daw, si DI lalagyan ng address na 4000H. So ginawa siyang immediate addressing node. So ngayon si DI magiging may bracket na naglalaman ng 4000H. So yung 4000H na to pwedeng maglaman ng kahit ano. So ngayon, i-move daw si DI ayun nga. So, explain ko muna. So, si number 2, retrieves this value using direct addressing mode. So, nag-direct addressing mode tayo and store it in AX. Sorry. Then, number 3, copies the value from AX to BX using register addressing mode. So, na register addressing mode, nilagay natin yung AX to BX. Tama. And then, for number 4, stores the value in BX at the memory location pointed by DI using register indirect addressing mode. So, ayun nga. So, DI, minove natin siya. May 4000H. Ngayon, gagamit tayo ng register indirect, which is BX to DI. Ito. So, anong nangyari lang muna dito? Kasi assume daw natin sa example is DI is equivalent to 4000H. So, in-immediate ko lang, nilagay ko dito itong buong to. Ito yung sinasabi sa questionnaire na assume daw na 4,000. So, in-immediate. Then ngayon, si DI na naglalaman ng 4,000H, may BX. I-move down natin yung value ng BX sa DI. So, ngayon, ito yung total. So, si DI, naglalaman siya ng BX, which is si BX naglalaman ng AX. Ang laman ni AX is yung 300H, which is 0x ABCDH. Itong total na to. So, ayan yan. So, DI will be equivalent to 0x ABCDH. So, nalipat natin lahat sa solution na to from 0 ABCDH, napunta natin sa DI. So, ayun, that's all for my solution.